Okay, we're back for our second video of our parametric skateboard. So we're going to get into some more variables today, and we're going to go through two sections of our skateboard. So we've got I've got this drawing made, and this is a sectional view of the skateboard we're designing. So we have a couple sections that we're going to be working on today. One is specifically the transition from this part of the board, and if we zoom in here, you can see that it's raised here, right, in the section, and then it tapers down to this plane. And so what we're going to work with first to get this first section is a work plane offset, all right? And that work plane offset is driven by, well, we're going to be using that in a part of our overall board length, right? So we've got to do a couple of things where we're working with our board length in that first extrusion. So we're going to change that first extrusion that we did in that other video and create more of a formula that is built into our skateboard. Okay, so the first thing we've got to do is we're going to create a couple of more variables. So you're going to see this variable list getting longer. And if you're wondering where we got these variables, you can check out the previous video and we talk about where these variables are coming from and how we're using them in our board. And the new thing that we're going to be introducing in class is our work plane offset. So we're going to hit work plane offset, and all this is doing is creating a piece of paper out in space. Okay, so you can see how it's got this little piece of paper, or this sketch plane. I call it piece of paper because you are drawing on it, but it's a sketch plane that's kind of out in space. But that sketch plane should have a certain distance, right? So we don't want to actually make that work plane offset yet. We want to start making some of our variables, and we're going to use, the first thing is our transition. Okay, and that transition we're going to start off at 2.5. Okay, and that's the transition from our curved concave portion of the board and to the flat section before it goes up into our kick. Okay, so we're going to say our transition is 2.5, and we're going to put that above our sketch here. Okay, and then we have the next one is going to be the board length. Okay, and this is the board length before the kicks are added into it. So when we're talking about board length in this sense, we're talking about what is the distance from this transition piece to the other transition piece. We're not talking about including the kicks. That would be the overall board length, and we'll get to that. There's a limit on how long these boards are going to be, because we can't have our stock is actually limited to 36 inches of board, so we can't get any longer than that at this point. So go back here, and we've got our transition to 2.5, and then we're going to create another variable called board length. Okay, and that one is going to be, what did I make it in my other one? Let's see. Board length 12 inches, yeah. So we're going to say board length is 12 inches. Okay, and we're going to bring that guy up here. Oh, I'm not supposed to put a hashtag in there. Okay. And then the last one is actually going to be a combination of the board length and the transition. So you have to have these listed before you make your next one. Okay, so our next one is actually going to be for the extrusion of our concave section. Okay, so our concave section is actually going to be board length and we're going to subtract out the two transitions for that concave section. And so we've got to have our two transitions in there because there's one on each side of the board. And so we're going to say transition times 2, and I think that should work. Hold on, I'm still getting used to how it likes to see things. How did I do the other one? Got it to work before. Board length, concave section. Okay. Board length, transition, times 2. Of course it wouldn't work in this video. Oh, that's why. Same mistake twice. Okay, so concave section is going to be our board length. Sorry about that. Board length minus our transition times 2. Okay, so we got 7 inches for our concave section. And so remember how I said in the last video we weren't actually going to keep that extrusion number. The extrusion number, we're going to change it to the concave section so that it's automatically driven by another variable, right? So that extrusion is going to change based on any of the other parameters that we put in there. Okay, so we're going to say concave section. All right. So now we can have our board length be a little bit longer, and that should actually be, so if each kick is somewhere in the distance of 6 inches, that would leave it would leave 24 inches for our board length. Okay, and so we'll just maximize it at this point, and we can actually take that down just a little bit. Let's take that down. Let's go 20 inches board length. Okay, there we go. I like that a little bit better. Okay, 15-inch concave section. That makes a little more sense. Okay, so we'll leave our board length at 20, and we're going to rearrange these and kind of identify a little bit later on what numbers are editable. And when we talk about in our video of, when we talk about a video of like how do you use this tool to customize a skateboard. And again, that's our end goal, is to really be able to customize a skateboard for someone and have it update our mold automatically, have it update all the measurements automatically. Okay, so now let's talk about how do we actually get that transition in there. Okay, I'm going to wrap this video up, and we're going to do the kick in another video after this. So you've got to know you've got to have your work plane, and we're going to start that work plane on the end of the skateboard right here. Boom. Okay, and the distance, the offset distance that we're going to work with is actually going to be the transition distance, because this is the transition right here. Okay, and so we're going to be transitioning from this curved part of the board, that concave part of the board, to the work plane here, and to a flat part. And so we'll start another sketch on that work plane. This isn't too crazy here. Okay, and this is actually where it gets a little bit easier for your board. We don't have to do so much crazy math in here yet. With the next video, get ready for the next video. That's when we're going to have to do some math. Okay, and so we want this to be the flat portion of the board, and so we just need a straight rectangle that's dimensioned to match up with the rest of our board. So we want that distance to be 0, and we want this distance to also be 0. Got pretty close there. And then this is where we're going to call a different variable, the thickness of our board. Remember how we want it to change? It is 0.5, but we want it to change in case, let's say we're designing a board for somebody who's 300 pounds. Well, we want our board to be thicker to be able to handle the pressure that person's going to be putting on the board doing jumps or tricks or skating around or whatever. So we want to be able to change the thickness of the board based on another variable. So we're going to use board thickness for that one. So 0.5. Boom. Okay. And so now when we change board thickness, this section of the board will automatically change. And now we just need to bring it up to the bottom of our board. So we got our dimension, and we're going to go to this guy right here, that center part of the board. Oh, that's not what I wanted. Too close to it. I'm going to drag this down a little bit. Okay, and then you guys can see where I'm going. I'm going from the center of this point right here all the way to the bottom of the board, and that should be 0. So bringing it up, and now we're going to have our transition go from this curved portion to that flat portion. Okay. Okay, so to do that, it's not a regular extrusion anymore. We got to use what's called a loft extrusion. And a loft just means that it's extruding from one shape to a different shape, and it's going to transition throughout the two sketches, and based on the distance of those work planes. So we're going to hit our loft. We're going to click on where we left off, and then we're going to click on our newest sketch here, and then we should see it transition there. Okay. So now you've got your transition on this side, and we're going to do the same thing to the other side. So we're going to start our work plane here. Okay, and I'm almost done here, just to give you guys a little extra practice here. So we're going to start another work plane, and that work plane is still going to be our transition, right? So we're going to say our transition. And then we're going to put our sketch on our work plane. Again, same sketch, just that rectangle. We're doing the same sketch on both sides. See how, and double check, be careful. If you use your tool, your rectangle tool, and it's locking and things are turning yellow on there, that means it's going to be constrained to it. And I like to do it off of everything so that nothing is on there, no constraints are on there, so that when we do dimension and we go to put the rectangle where we want, it's not already stuck to something. We don't run into anymore. We don't run into other issues. Okay, so make sure that when you're putting sketches in there, you don't have it constrained to anything. So we're going to go our distance here. Again, the thickness of that board is going to be a standard thickness that goes throughout the entire board, right? So we want to say board thickness is our variable that we're going to call. So it's already 0.5, changes it to 0.5. We're going to go from the edge of this board to here. We want it to match exactly, so it's 0. Want this guy to match exactly, and it's 0. And yet there's other constraints that we could use for that. We could use some geometric constraints. I just like using the numeric constraints. And then we can go from the bottom of our curve to the bottom of that part of the board, and that's also going to be 0. Okay. So now we can go, oops, I want to do a loft extrusion. We're going to go from here down to here. So both the transitions are the same on each side of the board. We could set it up if you wanted to get crazy and do fully customizable, where you have a kick transition or a kick tail transition and a nose, a tail transition and a nose transition that are different. We're just keeping them standard and the same in this one. But we are going to be able to do in our next video, we are going to do the kick, and that will be customizable for the front and the back, because it is not uncommon to have a board with a different kick for the nose than the kick for the front, or the tail. So that's coming up in our next video. I'm going to let you guys go, but just in a quick review, we added a couple more variables, and those variables, some of them are driven by other variables. So you want to make sure that you're following along and go back and double check any of the variables that we have in here that are kind of driven by other variables. So like the, let's see, I believe the concave section, right? The concave section extrusion. This one's driven by the board length. I can't get my mouse over there, but it's driven by the board length and the two transitions, okay? And that is what we're using for our extrusion. And then we also have our transition number, which is what we're using for our work plane. So if I change this to, like, let's say I change that to 7, watch what happens to our transitions. You can see that there's a huge difference in our transitions, and that math subtracted it out of the concave section. Okay, so we're going to say that our transitions are about 2.5. Okay. All right. So that's where we're at this point. I'm going to come back with my next video on doing the kicks and the trigonometry that goes into that. So look for that in the next video. Thanks for your time.